Good day, viewers all over the world. I remain Sanumaj. Today we're talking about mathematics. Under mathematics, we are talking about the basic principles in mathematics. So today I'll be talking about uh, lines. So the question is, what are lines, or what is a line? Let's say this is a point, and this is another point. Those in further mathematics will be very familiar with this. So we are talking about geometry, plain geometry. So let's say this is point A and this is point B. Point A to point B. Look, point A is a position. Point B is another position. But what is connecting these two together is called what? A line. What is connecting the 2 points together is what? A line. That's when we start talking about, okay, what's the distance between line A and line B? Then you started talking about what? Mathematics. Mathematics is all about calculations, solving problems. So now, I want to talk about some principles here now concerning this line. Because in mathematics, a line is a continuous, what do you call it, structure. It should not be continuous. It should continue, it's endless, provided we pick some points on that imaginary lines. If not, line will just be continuous to infinity. From A, if I didn't put B, it will just be continuous. And two lines, unless, okay, let me just continue. Understand what I'm trying to say? This one is a line. If not that I've started somewhere, you may not even know the beginning. It will just be continuous. From here to, well, this is the beginning, because I've started from somewhere. But the end, you may not know. So in mathematics, you try to pick some points on the lines, then work with it. Like, yeah, so we have point A, like we have A to B. Now, some properties will now come up that a line, for angles, lines and angles, that one of the trick today. Because without lines, you cannot form angles. Without lines, you cannot form angles. Then the question is, how do we form angles? We have understood the meaning of what? Line. So lines will only be from one point to another point. So angles now, let's say an angle is formed when two lines meet. Look at it. This line A to B, this other line C to D. Let's say this is A to B, this is C to D. The question I've asked, is there any relationship between line AB and CD? And in mathematics, if I want to write line AB, I will write like this, line AB. So when you see something like this, it means what? Line AB. Or in construction, they may say AB. So you should be familiar with this kind of mathematical representations. So the question is there any relationship between A and B? The question is no. This one is on its own. Why this one is what? On its own. That is why they will ask you the angle between these two parallel lines, because this line is parallel to this. The angle between these two parallel lines is what? Is 0 degree. Because there is no relationship between this line and this line. But now look at it. Let's assume that we have line AB and we also have dissection of what? AB by CD. This is a line. This is line CD. We already have AB, but CD is dissecting. Use my word, dissecting. And bisecting. So when I say bisect, it means to divide into two equal parts. But if I say dissect, it may not be equal. Like the one I've drawn now, AB has been dissected. It's not divided into two equal parts. So we have CD meeting AB at this point. This point. So C has intercepted AB. CD has intercepted AB at this point. Because this one has intercepted this at this point, they have formed what? Angle. 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 So we now say that what? An angle is formed when two lines meet. CD is a line, AB is another line, but they have met at this point, forming what? Different angles. An angle is formed when two lines meet. I think that is clear. Another thing we need to understand is that they will ask you, that you have line A, B, you have line CD. This is A, B, and you have C, D. And you have a line, look at this, this is another line. Initially, no interaction or no relationship between A, B, and CD. But this one running through CD and AB has brought a relationship between these two lines. I come over it again. This is line AB and this is line CD. Line AB and line CD, no relationship between the two because the angle between these two lines is what? Is 0 degree. But we now have another line running through CD and what? AB. So this line that runs through two parallel lines is called transversal line. This line that runs through two parallel lines, these two lines are parallel. So the line that runs through two parallel lines is called what? Transversal line. And transversal line causes three things to happen. Number one, it makes vertically opposite angle to be equal. The question is, what are vertically opposite angle? Look at this. You know, we have already formed different angles because this line has met this line at this point, forming different angles. This line has met this line at this point, forming different angles. We have different angles here. So I can name it. You know, in mathematics, I said you use alphabet to name unknowns. So you can say this is A, B, C, D. E, F, G, H. Now the question is this. When I say vertically opposite angles, vertically opposite, these are your angles. But the question is, which angles are opposite to each other? Look at this. G is directly opposite to what? E. So it means that angle G is equal to what? E. If angle G is 60 degrees, it means that angle E will also be what? 50 degrees. F will be equal to H. F is equal to H. D is equal to B. D is equal to B. A is equal to what? C. That is what? Vertically opposite angles are what? Equal. That is what transversal line normally cause. The second thing it will cause is that what? Two. Alternate angles are equal. Alternate angles are equal. What are alternate angles? Now look at it. It's just like you know all these people. the athlete in the race. As they are running, this hand is at the front, while this one is at the back. The two hands are what? Alternate to each other. If this one goes to the front, this one comes to the back. We say it is what? Alternate angle. So look at this one now. Let me now put it in that form. This is your hand. And so what are alternate angles? Alternate angles are the angles below the top line and below the top line and above the down line. I repeat, alternate angles are angles formed below the top line and above the what? The down line. Below the top line, which is AB, we have angle D and C. Above the down line, this down line, CD, we have H and E. Now, how do I now determine vertical, what do you call it, alternate angles? You now look at this. This H is alternate, like the way I did my hand. I will now say that H is equal to what? H is equal to what? C. And E is equal to what? D. E is equal to what? D. Reason. Alternate angles are what? Equal. The third condition that normally happens is that what? Corresponding angles are equal. Corresponding angles. Corresponding angles are equal. If I say corresponding angles, it means that the position on the lower line, the angles on the position on the lower line must be on the same position as the upper line. Upper line is AB. The lower line is CD. If I ask you now, what position can you find in A that will be the same thing as CD? That what we call corresponding angle. AB now, if I say pick A, if I pick A now, which angle is similar to angle A when you come to CD? Very simple. A is similar to what? H. Because they are occupying the same position. We say A is equal to what? H. Then you can ask, okay, if I pick, let me just pick anyone arbitrarily. C. If you check the down line, C corresponds to what? F. They are both under. C corresponds to F. Let me pick another one. Let's say G. G is equal to what? G is here. So D. They are the same position. So we say they correspond. Okay, let me pick E. E is corresponding to what? B. So these are the conditions that are made to be equal when you have a transversal line passing through two parallel lines. In our subsequent classes, we are going to be solving problems that has to do with what? Lines and angles. You know, we are still doing introduction to basic principles in what? In mathematics. By the time I start picking those topics one by one, maybe I want to talk about arithmetic progression and geometric progression. I'll just be doing some things. So those things I don't even need to re-explain it again, because if you can go through the basic principles I've taught, it will be very, very, very easy. Long and large, it will be very, very easy. Bearing and distances, elevation and depression. By the time I start teaching them, you know, giving you all these basics, make sure that you go back and watch the video over and over. If you have watched it one time, go back again and rewatch it so that you can get, because like I always tell my students that if I teach you, you can't understand it yet. You have to go over at least 10 times to understand the principle I'm talking about. Thank you very much for watching this video. Please subscribe. Let me thank my viewers that have been subscribing to my channel. God bless you all for motivating me. I'm really, really happy. And if you have not subscribed, please do so now so that you can get more videos from me. Thank you. God bless you. Shalom.